Hello, everybody. Good to see all of you again. It's not like I can literally see you or anything, but you get what I'm saying, lah. Welcome back to our series of IGCSE physics. So today we are going to focus more on density. Okay, let's get started. So density is defined as the mass per unit volume, and in simpler terms is basically just the mass divided by the volume. As you can see from this equation, this symbol right here, let me get the pen, this symbol right here is small p, it's not a p, it's actually called a rho. So in physics there are so many things, so many parameters. They got momentum lah, viscosity lah, power lah, work lah, force lah. In force some got gravitational, frictional, got electromagnetic pressure, got hydrostatic, got everything, got so many lah. Sometimes I don't even understand why. So that's why we are using this letter rho to represent density, because there's just so many parameters but we don't have enough letters to represent it. So as you can see, density is the mass per volume, is the mass divided by volume, and the SI unit for density is kg per meter cube. Sometimes it can be grams per cm cube, but just remember lah, when they ask for SI units, always ensure that the units are in kg per meter cube. So for water, the density is always fixed. It means in whatever situation, explosion ke, tsunami ke, corona ke, it will still be the same value, which is 1000 kg per meter cube. Why? Because the water molecules all have the same mass and all are spread evenly throughout the sample of water. So when you halve the volume, you halve the number of water molecules, you halve the number of mass. So in simpler terms, no matter how much you reduce the size of the water, the volume will also reduce in the same ratio, so density will always be the same. Okay? So how does density work? Density is actually what makes an object float or sink. If an object is less denser than the other, then it will float, and vice versa. For example, ice is less dense than water, so ice will float. Have you ever seen ice underground, underwater? No, right? So you have to see, when you see an iceberg, like how the Titanic hit the iceberg was underwater because it has lesser density compared to water. That's why it's floating in the water. So another example, iron is denser than water. So when you see iron, when you drop iron inside the water, the iron goes down, right? Why? Because iron is more dense, so therefore it will sink in the water. So in this slide, it shows the density of waters. It shows the density of waters in different units. But the two most common ones, it usually used is 1000 kg per meter cube and 1 grams per cm cube. Others you may use in some certain examples, but most of the time they will ask you to give your units in kg per meter cube or gram per cm cube. Alright. So this is the densities of other substances. So generally, gas has very low densities compared to solids and liquids. As you can see, air, the density of air is 1.29, where liquids, water, let's say water, 1790 for alcohol, and see the solids 920, 400 to 1200. As you can see, is way bigger than compared to gas, and of course the solids is way bigger than the liquids, the density. So as now you can conclude that gases has always the lowest density compared to other phases. So calculating density. In this example, sample of alcohol has a volume of 200 centimeter cube, and the mass of the alcohol was measured to be 150 grams. So what is the density of the sample in grams per cm cube? So is this in SI unit? No, it's not in SI unit because it's in grams. SI unit is in kg per meter cube. Alright. So the first step is to list down the values first. So the volume we have obtained, or volume that is given, is 200 centimeter cube. So you write down the V is equal to 200 centimeter cube, and the mass is 150 grams. So you just write down. So what is the density? So remember, the formula of density is equals to mass per volume. So calculate the density now. Density equals to mass per volume. You substitute the values inside. 150 grams divided by 200 centimeter cube, then you get a density 0.75 gram per centimeter cube. Always remember to write down the units. In this case, In this case, you do not need to change any of the units because it's already in the form of the unit that you want to answer. So you don't really need to change anything here. It's just a straightforward process, and you got your answer 0.75 gram per centimeter cube. So next, example 1. Okay, I've given you the formula right here. The student places a block of cube with a length of 6 cm on a measuring scale. The mass was then recorded by the student, and the mass of the cube is 100 grams. Find the density of the cube. But I can also show the answer in SI unit. Alright. So first of all, you have to write down the values. The first value, the length is 6 cm for the cube. So what we have to do, you have to draw the cube and you have to determine the volume of the cube. The mass of the cube was then recorded by the student. The mass is 100 grams. Okay, so the mass of the cube is 100 grams. So what we have to do, you have to determine the volume of the cube. So how do we determine the volume of the cube? So the cube has equal lengths. The length, the width, and the height is the same because it's a cube. So that's the general principle of a cube. So the volume of a cube is the length times width times height. So 6 times 6 times 6, you'll get 216 centimeter cube, which is the volume, and the mass is 100 grams. Okay, so now you have the mass, now you have the volume. Alright, so the second step is to find the density. So density is equal to mass per volume according to this formula that I've given to you. So you just substitute the values inside and you will get 0.463 gram per centimeter cube. Okay, so this 3 dp, it means 3 decimal places. It means the value that I've obtained from my calculator is more than 3 decimal places. So I just limit it down to 3 decimal places. As you can see, 1, 2, 3. Alright, so that's 3 decimal places. So how do we show this answer in SI unit? So in SI unit, so as I've said just now, SI unit is in kg meter cube. Okay, so what do we do now? So the mass is in grams, right? So 100 grams. Do you want to change it to kg? Yes, because you need it to be in kg. So 100 grams divide by 1000, and you get the mass of the cube in kg. So 0.1 kg. Alright, next you have to convert the volume into meter cube. So 216 centimeter cube, to convert to meter cube is, you have to convert the 6 cm into meters. So 6 cm convert to meters is 0.06 meters. So 0.06 meters times 0.06 times 0.06, you will get your answer 0.000216 meter cube. So this is your volume in meter cube. So this is the 2 values that you have obtained. So you just substitute these 2 values into the density and you will get your answer. As simple as that. Alright, next, example 2. Okay, calculate the density of mercury if 500 centimeter cube has a mass of 6.60 kg. Alright, so give your answer in gram per centimeter cube. Okay, so now they want your answer in gram per centimeter cube, but you have your value of your mass is in kg. So what you have to do is first you have to convert. So mass is equal to 6.60 kg. Alright, and the volume is equal to 500 centimeter cube, so we won't disturb that. So what do we do with the mass? So mass of mercury now is 6.60 kilograms times with 1000, you get 6600 grams. So that's the basic conversion from kilograms to grams. And the second step, you just find the density, substitute into the formula, mass per volume, and you'll get the answer 13.2 gram per centimeter cube. Okay, alright, so that's all for this video today. Thank you for watching. Don't forget to like and subscribe, and also if there's any other questions, you can drop it in the comments below and I'll try to answer it. Till next time, peace out.
うちに今さら説教か遅すぎやしな。あんたはいつも肝心な時に遅すぎを諦められた。哀れだな。いうほかげとして死んだあんたが息子の前で生き恥をさらしている。今の俺と比べれば哀れな存在でしかない。なんだ俺の父ちゃんをバカにすんじゃねえ。やば かりそうだ